Hello, fifth graders. Today we're going to talk about prime factorization and how we take any whole number and we break it down to find all the prime numbers that make up that whole number. Today's first number that we're going to look at is the number 36. Now when we look at this number, we ask ourselves the question, how could I break this number down? What two numbers equal 36? Now, I split my 36 in half here with a caret. I say, what two numbers multiply together to equal 36? Now, there's a couple of different options. I could do 9 times 4, I could do 6 times 6, I could do 2 times 18. All those factor pairs will work. So you just need to choose one. It doesn't matter which one you start with. So I'm going to start with 4 and 9. Now I've split 36 down to 4 and 9. Now I ask myself, is either 4 or 9 a prime number? If it is, I circle it just like we talked about in class because I'm done with it. I found one of the prime number components of the 36. Now I ask myself, is 4 a prime number? Well, what are the factors of 4? The factors of 4 are 1, 2, and 4. And to be a prime number, you can only have two factors, or one factor pair. With factors of 1, and I'll even write these out here, 1, 2, and 4, that's more than one factor pair. That's actually two factor pairs, 1 and 4 and 2 and 2. So it's not prime yet, so I need to break it down once again. Now 4 breaks down, 2 times 2 is 4. Now 2 I know is a prime number, it's the only even number that's prime, so I'm going to circle those because I found part of the prime root of the 36. Now I'm left with my 9. What do I need to do? I need to figure out if this number is prime or composite. Once again, I know that a prime number is a number that has one factor pair, the number itself, in this case 9 and 1, and if those are the only factors, it's prime. Well, I know a combination of two numbers that multiply together to equal 9 that is not 1 and 9. It's 3 and 3. Now, because it has the number 9 has more than one factor pair, I know that this is a composite number. So I'm going to break 9 down into 3 times 3. And I know that 3, based on what I know about prime numbers, 3 and 1 are the only factor pairs. These numbers are prime as well. So our final answer is 2 times 2 times 3 times 3. Now, depending on what we've talked about already in class and when you watch this video, there's another way that you could rewrite this. 2 times 2 is the same thing as 2 squared. If you watch the video on exponents, you know that the little 2 up top doesn't mean 2 times 2, it means, well, in this case it actually does. It means 2 times this number, so 2 times 2. Then we multiply that with, and I'm going to switch my marker over here, 3 squared, because 3 squared, let's circle this, equals the 3 times 3. And the 2 squared equals the 2 times 2. So we can rewrite, and that's a little bit messy there, but we can rewrite 2 times 2 as 2 squared times 3 squared. Now if I were to do this problem a different way, and I just want to do this so I can prove it to you. If I had 36 and I broke it down into 2 and 18, 2 is prime, so I'd circle it. I break this down to 9 and 2, I'd circle it. It breaks down to 3 and 3. Now, what do you notice about these final numbers that are circled compared to these 4 numbers that are circled? Take a peek, you'd see that these numbers are exactly the same. So you'd say, oh, Mr. Weiner, I can do whichever way I want. So don't get caught up on saying, which way should I divide it down? Just think about what's one way that I know I can divide it. If you can find the one way to divide it, you're going to be golden. You just work your way lower and lower until you end up with all prime numbers. And this is prime factorization. If you have any questions, let me know. Thanks.